chi-square statistics for the model testing. Is the model better than nothing? These are the degrees of freedom from each of those models, right? So when I compare this model versus this model, I looked at the difference between these log likelihoods. That's going to be chi-square distributed with 2 degrees of freedom. 3 minus 5 is 2. Right? So that difference is about, I don't remember what it was, 8 or something like that. Because it's negative 2 log likelihood, and that's going to be statistically significant. So this is an interesting way of sort of presenting all of your results all at once. Copy paste that into Excel. And
can you see the adjusted R squared as well? The comparison between all?
Oh, to see, no, you'd have to sort of keep track of that. I wish you could.
So the 4 numbers again, I'm sorry.
So this is going to be the odds ratio. Those are down here. These are the odds ratios, the standard error, the z statistic, and the p-value for the z statistic. But really, if you think about it, if you take a step back for a second, we haven't learned really anything much new today compared to what we did when we did regular linear regression, right? We learned about comparing models. We learned about, you know, it's a beta coefficient, so that's the expected value, a change in y for every 1 unit change in x. It's just, what is y? These are logit changes, right? So the only thing we have to do is turn that back into something that a human being understands, by exponentiating these things. But really, we haven't learned anything new, honestly. It's really the same thing we've been doing all along, right? Okay. So here's what I'd like to do, is Thursday, I want to talk about how we take this binary model, a model with binary outcomes, and we'll generalize it to multinomial outcomes, right? And there's tons of models that you can possibly fit, plausibly fit with multinomial outcomes. And in those cases, you really can think about the nature of your variable. Here it's kind of easy, yes, no, dead, alive. You know, low birth weight, non-birth weight, you know, not low birth weight. But imagine if you had a scale that's ordinal. None, some, more, most, right? That's ordinal. So we don't know the difference between some and more and most, right? If we were to think of that as an underlying continuum, right, and those points, those 4 points just become arbitrary cut points on that underlying continuum, you can fit really interesting models. There's so many different models that you can fit if you take a second and really consider the nature of what you're actually modeling. What's the question you're asking? So Thursday, what I want to do is I want to go over those kinds of models, and I'll also give you a homework assignment for the weekend that'll be based on logistic regression. Right? And then we can see how we can use, there is something called a simple multinomial model, which is where we have nominal outcomes, not difference in kind, but just difference in kind, not in rank or order or anything. Of which the logistic regression is a special case. So you can do it in a multinomial framework or a logistic framework, you'll get the same answer. So I have a data set that I want to use there where I look at vascular conductivity or something like that as a function of some other things. Okay? And Thursday we'll pick up, we won't do the models, like I won't give you homework assignments for these models. The idea on Thursday will be to, guys, you know, if you take a step back and think about the nature of your variables, here's the world that really opens up to you. There's tons of things that you can do. Tons and tons of things you can do. And then next week we'll do count models. So that'll be Poisson and negative binomial models. And then after that I want to do survival models. And then we'll see what we want to do in the last week. And then like the last class before the final will be a take-home. So to give you a sense of what the final is going to look like, I'm going to give you a data set with just a description of the data set. And I'm just going to allow you to do whatever you want with the data, given the description of the data set, and have you analyze the data, much like we've been doing in class. State a hypothesis, you know, even more specific the better, and then describe what you're going to do and why you're going to do it. analyze the data, interpret what you see, univariates, so if I give you a data set where regression might be in order, I'm going to look at for, bivariate correlations to look for suppression and possible collinearity, that sort of stuff, right? And then some softball kinds of conceptual questions. Like, I guarantee you I'll ask you the question, how are regression and over t-test plus sign negative binomial and logistic regression similar? Because that's what we've been talking about all semester. Okay.
Doug?
Yes, sir.
All right.
Wait for you to kick.